next section of the text, which is section dealing with slope and graphs of linear equations. And before we start that, we really need to define and understand what the slope of a line is. You can define the slope as, there's defined many ways. One way is it's to write it out, it's the change in y divided by the change, I don't see the change in x. That would be how you calculate the slope of a line. So in order to have a change in y and a change in x, we need to have 2 points. And then we can calculate the change between those 2 points. And that is the slope. Another way it's commonly defined as the rise over the run. Any of you that have worked in the building industry recognize that. Carpenters use that, rise over run, when they're calculating the slope of a truss or something like that. So that is the slope. The slope symbol in algebra is an M. So when you see this symbol, you know that they're asking, or they're talking about the slope. So let's take 2 points. Let's take a point which we'll call 0 and 1, and a second point 4 and 3. So we'll call this point 1 and point 2. And remember, this is an ordered pair, so this is our x value followed by our y value. So we could call this x sub 1, meaning the x for point 1, y sub 2, meaning the y for point 2, and the x, or the y for point 1, pardon me, this is point 1, and the x for point 2, and the y for point 2. Or we could say x sub 1 equals 0, that's the x for point 1, and y for point 1 equals 1, and x for point 2 equals 4, and y for point 2 equals 3. We just pull them from the places they are on the points. Now, we said the slope was the change in y. To get a change in y, we're going to have to subtract one y from the other. And to get a change in x, we're going to have to subtract one x from the other. Now, it doesn't make any difference in which we subtract from which. But what is important is that if you subtract the y from point 2 from the y from point 1, then you have to subtract the x from point 2 from the x in point 1. You could also subtract point 1 from point 2. And I'll show you this in a minute, but it doesn't matter which one we subtract from which, as long as we're consistent and subtract the y's from 1, from the y from 2, the x from 1, from the x of 2. Doesn't matter if you subtract 2 from 1 or 1 from 2, as long as you're consistent with your x's and your y's, okay? In other words, you can't subtract, this will not work. If you subtract point 1 from point 2 for y, you can't subtract x from point 1 from x from point 2. You have to subtract the 2 from the 2 and the 1 from the 1. This will not work. You'll get a wrong answer. Don't do it that way. All right, well, let's, I had 2 points here, 0, 1, and 4, 3. This was point 1. This was point 2. And we're going to calculate the slope. And the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So our y value from point 2 is 3. Subtract the y value from point 1, which is 1. Divide that by the x value from point 2, which is 4, minus the x value from point 1, which is 1. Or it's 0, pardon me. It's 0. So what is the slope? Well, 3 minus 1 is 2, and 4 minus 0 is 4. And that's 1/2. So the slope of the line is 1/2. Let's try it the other way, where we subtract y sub 2 from y sub 1 and x sub 2 from x sub 1. So again, we'll look at our points here. Our y1 is 1. Our y2 is 3. Our x1 is 0. Our x sub 2 is 4. 1 minus 3 is a minus 2. 0 minus 4 is a minus 4. Minus 2 divided by a minus 4 is 1/2. So it didn't matter which point we subtracted from which, we still got the same slope. The slope is 1/2. What does that mean? That means that on a graph, if we had a point on this that we knew was on the graph of this line that has this slope, it would mean that the slope is 1/2. That's the change in y divided by the change in x. This little delta, that little triangle, is a Greek letter delta. And when you see a delta in mathematics, it means change. So this is like saying the slope equals 1 over 2, which is the change in y divided by the change in x. So what's the change in y? It's 1. So it'd be positive 1. It's a positive number, so it'd be 1 up. And the change in x is 2. X goes across like this. This is 1 to 2. The slope is represented by this diagonal. So if we knew this was a point on the line and we knew the slope, we could extend the line on indefinitely. All right, that's what the slope is. Well, let's work an example in the book. Example number 1. Find the slope of the line passing through each of these pairs of points. We have a -2 and 0, and 3 and 1. And we said the slope is going to equal y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't matter which point is number 1 and which point is number 2. We'll call this number 1 and this number 2. So the y value for number 2 is 1. The y value for number 1 is 0. The x value for number 2 is 3, and the x value for number 1 is a -2. So we're going to subtract a -2. You remember from basic math that when you subtract a negative number, it's the same as adding it, right? Minus a minus is a plus. So this is 1. 1 minus 0 is 1. Over 3 plus 2 is 1 over 5. The slope of the line is 1 over 5. The change in y is 1 for every change of 5 in x. All right? And the second point in this example, find the slope between 0 and 0 and 1 and a -1. So again, our slope equals y2 minus y1 over x2 minus x1. We'll make this point 2 this time, and this point 1, doesn't matter which is which. So our y from point 2 is 0. Our y from point 1 is 1 minus a -1, divided by x from point 2, which is 0, minus x from point 1, which is 1. So this is 0 minus a minus is a +1 over a -1, or our slope is a -1. Or you could write it a -1 over 1, which means that for every change of 1 place in y, you have 1 place in x, and it's a negative. So if you were on a coordinate system, if you were doing a graph of this, and we're working with a negative number, we have to change 1 in the y and a -1 in the x. So our slope would be down like that. Or you could go a -1 in the y and a +1 in the x would still give you a negative, and you'd still have a slope that looked like that. The slope would still be in that direction. If they were both positive, the slope would be in this direction. +1, +1. +1, +1. In this case, the slope would go in that direction. All right. That's the end of example 1, problem 1.